Okay, so if you haven't already written what's in pink at the top, go ahead and write that. A composition is more than one rigid motion happening together, so a sequence or a combination, as somebody brought up today. I like that word. So down below it says a composition function is a term for when a sequence of transformations takes place. That could be a reflection and then another reflection. That could be a reflection and then a rotation. Could be a rotation, then a translation, or any two, or really it doesn't have to be just two, but we'll probably just focus on mostly combos of two. The notation is the tricky part. So I'm going to give you an example. If we were going to translate, say, over 3 and down 4, then we wanted to reflect over the x-axis. If that's how we wrote it in English and said it in words, it would actually be written like this. You reflect over the x-axis after translating 3, -4. So first of all, you notice this little circle. It's bigger than a dot, bigger than a multiplication sign, smaller than a degree marker, and it's right in the middle. It's like a little empty circle. And that means that's function notation for like 2 steps. But notice that the first one is here. This is what you do first, and this is what you do second. So you work backwards, and that's the biggest thing to understand with composition of any function in math, is that you do this first, then you do this second. You work backwards, and then you're doing it to maybe triangle ABC. So what that would say is, you start with triangle ABC, and you do this, then once you have that answer, you take that new one and do this. So it's written in reverse, and it seems like no matter how many times we say that, the human brain wants to operate left to right because we're used to that, and people make the mistake and do this first. But that's not the case. You always work backwards. So let's look at this notation here for number 1. We're starting with the point -1, 4, which is right here. There's point A. The first thing we do is what's right next to it. Again, we're working backwards from right to left. So first we're going to translate over 1 up 2. All right, so there's A prime. We went over 1 and up 2. Now we're going to reflect over the x-axis with our newest point. So we take A prime and reflect over the x-axis. There's A double prime. So again, we worked from right to left, translating and then reflecting. You can use the same piece of graph paper, or you could flip back. We didn't use some graphs in the translation section, so if you got messy, you could go back to those pages and use them. But I'm going to start fresh here with -2, -5, which is right here, and that is point B. Then it says the first step, working this way, is to reflect over y equals x. Remember, y equals x is this perfectly diagonal line. And if the point was -2, -5, you might remember the shortcut was either count diagonals to that line, which is, let's get a better line there. It's 1.5 diagonals, so 1.5 diagonals. There's B prime. Or you could just reverse the coordinates. So -2, -5 becomes -5, -2. Either way works for you. So now I have B prime, and I just have to translate it over 2 and down 1, which ends up right on that line, but that's just a coincidence. B prime ends up at -3, -3. Okay, the third one is over 1 up 2 is the original point. That would be called point C. And the first thing we do, working backwards, is rotate 90 degrees. So you take your patty paper out, And if you don't see the center of rotation, it's assumed to be the origin. I don't like that, but sometimes they don't write the center of rotation, and if that's the case, it's assumed to be the origin. So remember that as we rotate this 90 degrees, which is to the left. So that becomes the point -2, 1, which we then translate over 7 and up 3, which is C double prime. And that ends up being at 5, 4 when you're all done. And number 4 says start with the point 5, 1, which is point D. We are going to reflect over the y-axis, which would put it over here, right? That being the y-axis right here, puts us at -5, 1. And then it says reflect over the origin. Now that's something new we haven't done yet. Reflect over the origin is another way to say rotate 180, but I'm going to show you right here. How do you get to the origin? You go over 5, down 1. So do it again, over 5, down 1. That's what reflect over the origin means. It's something new to you, but I just taught you. So there is D double prime after the second step, 5, -1. Now if notation is not used, and by notation I mean like this type of mathematical notation, function notation, if it's written in English and it just says a translation of this followed by that, then you don't do anything backwards. If it's written in words, you just do it as the English words say. So the first thing I'm going to do is translate it 3, -5, because it's in words, not notation. So I'm going to move that entire triangle over 3 and down 5. I'll get fancy and do it this way. 1, 2, 3, 1, 2, 3, 4, 5. Then reflect it over the y-axis. Now you have an invariant point here because B isn't going to move as on the y-axis. That's going to be A prime, and that's going to be C prime. So that would be the second step after the translation and then the y-axis. Again, we have another one that's in English. So in English, you don't change anything. You rotate, then you translate. Only when it's in function notation do you do it in reverse steps. So the first time it says rotate, we use patty paper to rotate. And again, it doesn't say, actually it does right here, about the origin, about O. So we are going to rotate 90, but first don't forget to trace your figure so that you know where A, B, and C are going to end up when you rotate. Which is right there. Then you're going to take that triangle and translate it over 3, down 5. So I'm going to take this triangle and now go over 1, 2, 3, and down 1, 2, 3, 4, 5. And that would be your double primes. First step, second step. Not to be confused with notation when you work backwards and it's first step, second step when it's written in mathematical function notation. So make sure you have those notes complete, that you understand them. Watch them again if you need to, and we'll take it from there tomorrow.